Hello everyone. This is Mohammad Iqbal. Okay, I'll be discussing a problem from the chapter on limits today. So, limit. Hello, Athawa. So, as you know, limit is the starting chapter from calculus. Calculus is the most important topic in mathematics. Even though calculus consists only of about 50% of class 12, sometimes in entrance exams, the 50% of the entire syllabus, entire questions in an exam will maybe from calculus. There have been instances where 50% of questions have been from the calculus part itself. Okay, so I'll quickly do a question from one of the simplest topics in calculus, which is limits. So let's do one question. This is limit x tends to 0 root over 1 plus x minus 1 divided by x. Okay, so when you look at the question, the first thing that comes to our mind is directly put x is equal to 0. So when you put x is equal to 0, what do you have in the numerator? When you put x is equal to 0 in the numerator, it is going to be 1 minus 1, which is 0. In the denominator, it is 0. So this is basically a 0 by 0. 0 by 0 form is called an indeterminate form. So there are other indeterminate forms as well. 0 by 0 is the most common indeterminate form. So here comes the question of evaluating the limits. Okay, if we had got an answer directly, we would have been happy with that answer. But in this case, we are stuck with this expression. Okay, so we need to look for ways to solve this question. So I'll tell you different ways to do this question. Okay, so one way to do this is when you put x is equal to 0, you observe that the numerator is becoming 0. And when you put x is equal to 0 in the denominator, you observe that the denominator is turning 0. So x is the term which is causing the trouble here. So we need to get rid of x. So what am I going to do here? I'm going to multiply with the conjugate of the numerator, this expression, on both numerator and denominator. So that is a tricky part here. So the question becomes limit x tends to 0. This is root over 1 plus x minus 1 by x into, I'm going to multiply with the conjugate. So root over 1 plus x plus 1 divided by root over 1 plus x. Okay. Now look at this expression. Now this is limit x tends to 0. And when you see the expression in the numerator, it is in the form a minus b into a plus b. So a minus b into a plus b is a squared minus b squared. So it is going to be 1 plus x minus 1 whole divided by x into root over 1 plus x plus 1. Okay. So 1 get cancelled and you see x gets cancelled. Okay. So finally limit x tends to 0 1 by root over 1 plus x plus 1. Okay, now we have got rid of x, which was causing trouble. Now you can directly substitute x is equal to 0 in the expression, and that gives us the answer. The answer is simply 1 by 2. Okay, I hope this is clear. Yes.
Yes, sir.
So I'll do other ways to do this as well. If you have any doubt in this, do let me know. If you have any clarification in this, let me know. Otherwise, we'll just go to the next way of doing this. So the second way to do this, okay, so our question is limit x tends to 0 root over 1 plus x minus 1 by x. As I said earlier, this is in the form 0 by 0. Okay, I'll teach you a trick to solve questions of the form 0 by 0. So this trick is called L'Hopital's rule. This is not pronounced as L'Hospital, it is pronounced as L'Hopital. Yeah, which way is easier? See, of course, this L'Hopital's rule is not in this NCERT syllabus. This you can't use in a board exam. But for entrance exam, a lot of questions on limits can be solved using this L'Hopital's rule. You should remember that as long as this question is in the form 0 by 0 or infinity by infinity. As long as the problem is infinity by infinity form. Yeah, Adava has raised his hand. So, yeah, please tell me.
Sir, so my question was, which way would be easier?
Yeah, which way would be easier? So we'll just see that this using L'Hopital rule, this question is going to be much easier.
Okay.
But there's a catch. Okay. You can't go and use L'Hopital rule always because it works. First of all, it works only for expressions in the form 0 by 0 and infinity by infinity. There are other indeterminate forms for which L'Hopital rules cannot be used. Secondly, L'Hopital rule should not be used whenever there are complicated expressions because the differentiation would be tedious. For example, you have a lot of complicated irrational expressions or trigonometric functions because trigonometric functions other than sine and cos, other trigonometric functions when you differentiate, it is going to produce bigger functions. Okay, so always careful when you're dealing with irrational expressions or trigonometric functions. Okay, third thing is once you use L'Hopital rule, the expression we get after doing a differentiation, okay, after doing L'Hopital rule, if you are going to get again similar expression, again 0 by 0 form, okay, you need to keep using the rule again and again. Okay, so in those cases, you should try to avoid L'Hopital rule. Anyway, let me tell you what the rule is. So if you have a function like this, if you have a limit like this, limit x tends to a, fx divided by gx, okay, and suppose this is in the form 0 by 0. So that is, if you substitute x is equal to a in the numerator is tending to 0, you put x is equal to 0 in the denominator is tending to 0, we said that it is 0 by 0 form. Or if you have an infinity by infinity form, okay, and this rule says that, okay, we can't go to the proof right now because it's way beyond the syllabus. So what this method says that this is nothing but limit x tends to a, f dash x by g dash x. Okay, f dash denotes the derivative of f, g dash denotes the derivative of g. Okay, here remember we are not differentiating using the quotient rule. We are differentiating numerator and denominator separately. Always remember. Okay, always remember this. We are not using quotient rule. We are differentiating the numerator and denominator separately. Okay, and as I just mentioned now, we know in this expression there are derivative terms involving. So whenever there are functions which are tedious to differentiate, for example, trigonometric functions, irrational functions, we should try to avoid it as far as possible because we might be able to do it much easier using other ways. Okay, and the other point I said that if we end up getting again, see, after using L'Hopital rule, if we end up getting one more term, one more function of the form 0 by 0, okay, we have to keep using that again and again. For example, if I have sin x minus x by x cube, suppose some question is this way, limit x tends to 0, sin x minus x by x cube. Now, suppose if I use L'Hopital rule, okay, because it is in the form 0 by 0, now this is going to be limit x tends to 0, sin x derivative is cos x minus 1 by 3x square. Now we are stuck again because we have, again, if you put x is equal to 0 in this expression, it is going to be 0 by 0 again. Okay, of course, this is a very simple question. This can be done using other methods as well. But to give you an idea, what I'm saying is, whenever differentiation is going to become more and more tedious, or it keeps recurring, the differentiation part keeps recurring, please try to avoid it. Now, this question can be easily solved using L'Hopital rule. I hope this is clear. This question can be done using L'Hopital rule. So this is limit x tends to 0, root over 1 plus x minus 1 by x. Okay. Now I'll just differentiate the numerator and denominator separately. So this is limit x tends to 0. What is derivative of root x? Derivative of root x is 1 by 2 root x. So this is going to be 1 by 2 root over 1 plus x, okay, divided by derivative of x is 1. Now you can directly substitute x is equal to 0. Our problem is solved. So the answer is 1 by 2. So here in this case, we got the answer in just one step. Okay. Let's see. Let's see whether you have understood it. I have shared a poll. Okay, please answer me. I've sent you a question. Okay. Okay, thank you. Okay, cool. Okay, I also tell you one more way to do this problem. Okay, in this question, this method is not very time saving, but you should be able to know this method. You know what happens in an exam is you can't do it in the easiest way. The easiest way is the one that strikes you the earliest. Okay, so for every question, you should be able to do it in multiple ways because you don't know what strikes you the first during an examination, right? Okay. So this is limit x tends to 0, root over 1 plus x minus 1 by x. So what I'm going to do is I'm going to substitute x plus 1 as y. Okay, this is another method using substitution. Okay, when you put x plus 1 is equal to y, our new variable is y. So whenever you make a substitution, let's see what happens to the limit. So x is tending to 0. So in this case, y is tending to what? 1. Okay, now our question becomes limit y tends to 1. The numerator is going to be root y minus 1 divided by x is going to be y minus 1. Okay. Now after this step, you can either cancel off one of the term because y minus 1 can be written as root y minus 1 into root y plus 1. So root y minus 1 can be cancelled off. That is one way of doing it. Otherwise what you can do is, yeah, right. Athava, you are right, because this can be simply written as limit y tends to 1 by root y plus 1. Now when you put y is equal to 1, you have the answer 1 by 2. Otherwise, we have a standard form. Okay, I'll tell you what the standard limit is. Sorry. I'll tell you what the standard limit is. Standard x. Yeah. We have the standard result limit x tends to a, x raised to n minus a raised to n by x minus a is n a raised to n minus 1. Limit x tends to a, x raised to n minus a raised to n by x minus a is n a raised to n minus 1. This is a very popular result. This is a standard limit. Okay, now this question can be written in that way. See this limit y tends to 1. This is y raised to half minus 1 raised to half divided by y minus 1. So the answer is, instead of x we have y, instead of n we have half, instead of a we have 1. So the answer is simply half into 1 raised to half minus 1. Again, the answer is half. Okay, cool. I hope this is clear. Right. Okay, I'll give you one more trick to do this problem. Okay, again, in this problem, it may not be an optimal way, but again, some question, that will be the only way you can do the problem. Okay. So you should be able to do it in multiple ways. Okay. So this trick is based on binomial theorem. Okay. So 1 plus x raised to n, 1 plus x raised to n is given as 1 plus nx plus n into n minus 1 by 2 factorial x square, so on. Okay, this is not a regular binomial theorem. Regular binomial theorem is 1 plus x raised to n is equal to nc0 plus nc1x plus nc2x square. Okay, and this is called binomial theorem for positive integral index, which means n is a natural number. Okay, and this is what we call binomial theorem for any rational index in which n is any rational number. N is any rational number. Okay, so in this case, what am I going to do? In this case, if we have an expression of the form 1 plus x raised to n, and x is a very small number, x is tending to 0, right? Okay, so I can approximate this as 1 plus nx. Okay, in some cases, you might have to take the second order term as well, but in this question, we'll be happily approximate 1 plus x raised to n as 1 plus nx. Okay, so in this question, we have limit x tends to 0. This is 1 plus x raised to half minus 1 by x. Okay, I'm going to use this result. Okay, why have I approximated it? Because x is a very small number and x is tending to 0. So higher order terms can be neglected, but that needs to be checked on case to case basis. In this case, we can simply write 1 plus x raised to half as 1 plus half x minus 1 by x. See this magic? 1 gets cancelled, and afterwards x gets cancelled. The answer is half. So that is another way of doing this. Okay. Yeah, I hope this is clear. We have done it in different ways. During an examination, we don't know which method will strike us, because the questions won't be always a standard question. Always you use a formula and plug it in the question, you get the answer. It won't be that way. Okay. Okay, I hope this is clear, and thank you for attending class.